In this video, we're going to solve 2006 AP Calculus ABFRQ, Form B, question number 1. Let f be the function given by f of x equals x to the third divided by 4 minus x squared divided by 3 minus x divided by 2 plus 3 cosine x. Yuck. Let R be the shaded region in the second quadrant, bounded by the graph of f, and let S be the shaded region bounded by the graph of f and the line L, the line tangent to the graph of f at x equals 0 as shown. Okay, so we're probably going to need that part right there. So if you look over here, if you need an equation for this, that's going to be y equals 3. It appears to be negative, so now you just need 2 points to figure out the slope. Luckily it's a line. So it went down 1 over 2, so minus 1/2 x. Okay, anyway, first question says, find the area of R. So we need to find where it intersects here. So if you use your TI-89, you're going to do solve. And you're going to do x to the third divided by 4 minus x squared divided by 3 minus x divided by 2 plus 3 cosine x equals 0 comma x. And then it's going to give you a bunch of different values. But the one that you really want is negative 1.373. It also gives you another value for the positive side, 1.373. But we don't need that one. So now, if we want to find our area, we have enough information to do this. We would do the area is equal to lower bound, so it's negative 1 to 0. Lower to upper, B to A, 0. And this would be f of x dx. Or, if you actually want to write in the function, negative 1.373, 0, f of x was that whole mouthful of a function that we said earlier. And when you solve this, your area should be approximately, let me make that into equivalent, or approximately 2.903. Okay, part B says, find the volume of the solid generated when R is rotated around the horizontal line, y equals negative 2. Okay, so if you have the function, I'm going to draw this very small. So if you have this function, and that's of course the x-axis, and you rotate it around, let me do red for the x-axis. So, and now let's do a different color for y equals negative 2. Let's do a blue. So if you rotate it around this line, you would get something that kind of looks like this. So now, so we're trying to find the volume. So it's going to be outer minus inner, and please forgive my drawing. I never said I was good at this. I always say I'm really bad at this. And it would be a bunch of washers, and same thing over here. Okay, etc. Okay, so anyway, now we have to figure out how to do this. So volume would equal pi the integral negative 1.373 to 0. And now we have to find how big is this piece right here, upper minus lower. So you're basically finding from here to here. Let me use a different color because I don't think you could see that. Let's use a white. I think you could see the white. So how big is this? So in this case, it would be f of x. Now, it's around y equals negative 2, so it's 2 more. So plus 2, quantity squared. It's outer squared minus inner squared. And now gray color. I think we could see gray. So if we want to find this radius, that'd be minus 2 squared dx. And this is a nightmare to type into your TI Inspire or TI-89. So when you do it, it's going to be v equals pi negative 1.3730. F of x was that function x to the third over 4 minus x squared over 3 minus x over 2 plus 3 cosine x. Wow. Plus 2 quantity squared. And now let me zoom out a little bit so I have more room to work with. Okay, minus the 4. Because that's 2 squared. Or you could say 2 squared. 2 squared is probably better to use. So minus 2 squared dx. And after you type it into your calculator and make sure it looks correct, you should get approximately about 59.361. Okay, part C says write but do not evaluate an integral expression that can be used to find the area of S. Okay, so it's top minus bottom. So now you'd have to solve where these points intersect. So you'd have to set this minus, so you would have to do 3 minus 1/2 x minus f of x. And I'm going to just abbreviate. You'd have to use your calculator. Solve f of x equals 0, comma x. And after you solve, you're going to get 3.390. Okay, so that's going to be our upper bound, 3.390. And this would be 0. Now it would be the line, top minus bottom. So line minus that function. So the line we found before, 3 minus 1/2 x minus f of x dx. And I'm just going to leave this like this. Okay, I hope this video helped.